In this video, we obtain our reduction formula for integral of cos to the power nx dx and then evaluate the integral of cos to the power 6x dx. Let's do it. We assume integral of cos to the power nx dx be equal to in. So let integral of cos to the power nx dx equal to in. Now somehow we want to apply integration by parts. That says that integral of product of two function equal to first function times integral of second function minus integral of derivative of first function times integral of second function, but this product has to be integrated once again. So we want to apply integration by parts. So we write cos to the power nx dx is cos to the power n minus 1x times cos x dx. Now you see that you got product of two function and we apply the product rule. First function times integral of second function. Let's write integral of cos x first. Integral of cos x dx. Again integral of cos x dx. First function is cos to the power n minus 1x. So u is cos to the power n minus 1x times integral of second, that's done, minus integral of derivative of first function, derivative of cos to the power n minus 1, that's equal to n minus 1 times cos to the power n minus 2x times derivative of cos x. Derivative of cos x is minus sin x. Oh, but you see that this makes sense only when n is greater than or equal to 2. So we assume n to be greater than or equal to 2. Of course, n is a positive integer. So this is equal to cos to the power n minus 1x. We copy as it is. Integral of cos x is simply sin x. Integral of cos x is simply sin x. Minus and minus can be cancelled, so we got plus n minus 1 times integral of cos to the power n minus 2x times sin x, but okay, let's write sin x only for the time being. Next step we can write sin x times sin x is sin square x. So we copy as it is, cos x to the power n minus x times sin x plus n minus 1 times integral of cos x to the power n minus 2x times sin square x. But sin square can be written as 1 minus cos square x. Dx we write as it is. Once again we copy this expression, cos x to the power n minus 1 times sin x plus n minus 1 times integral of cos x to the power n minus 2. That's simply I n minus 2. Okay, and then minus n minus 1 times integral of cos to the power nx dx. That's simply equal to in. So we find in equal to something that in term of in and in minus 2 and of course cos and sin. Okay, so we see that we can cancel in out and we will be simply left with n times in equal to cos x to the power n minus 1 times sin x plus n minus 1 times in minus 2. Lastly, we divide throughout by n and obtain in equal to 1 by n times cos x to the power n minus 1 times sin x plus n minus 1 by n times in minus 2. Now somehow we want to evaluate I6. Now for n equal to 6, I6 equal to 1 by 6 times cos to the power 5x times sin x plus 5 by 6. N is 6, so 6 minus 1 is 5, so 5 by 6 times I4. Again, for n equal to 4, I4 equal to 1 by 4 cos to the power 3x times sin x plus, if I choose n equal to 4, then 3 by 4 I2. Lastly, I2 equal to 1 by 2 cos x times sin x plus, if I choose n equal to 2, 2 minus 1 is 1, 1 by 2 times I0. How much is I0? I0 is simply integral of cos to the power 0x dx, that is just 1, and integral of 1 is simply x. So I0 is simply equal to x. Okay, now we simply need to plug in the value of I4 and I2 and we get the result. So integral of cos to the power 6x dx equal to 1 by 6 cos to the power 5x times sin x plus 5 by 6 I4 is 1 by 4 cos cube x times sin x plus 3 by 4 times I2. That's equal to 1 by 6 cos to the power 5x times sin x plus 5 by 24 cos cube x sin x plus 5 times 3 by 6 times 4 I2 is again 1 by 2 cos x sin x plus 5 times 3 by 6 times 4 times I2 we wrote 1 by 2 times cos x sin x and then half x. Well, we can cancel 3 and say that final answer equal to 1 by 6 cos to the power 5x times sin x plus 5 by 24 cos cube x sin x plus 5 by 16 cos x sin x plus 5 by 16x, of course with some constant of integration as well.